Imagine standing inside an ancient cathedral, cold stone beneath your feet, dim light filtering through massive stained glass windows, an air that feels so heavy it seems saturated with centuries of history. Beneath these slabs, in the silence of the ambulatories, lie the remains of people who once ruled half of Europe. Emperors, conquerors, titans of spirit and sword, figures who changed the destiny of an entire continent. Yet, a quiet, unsettling question has always hung over their tombs. What if these bones are not actually theirs? For centuries, no one could provide a definitive answer. Tombs were opened, moved, and restored, while relics passed through thousands of hands. Wars, fires, reconstructions, and lootings layered on ever more uncertainty. And yet, people believed. They believed that Otto the Great, one of medieval Europe's most powerful rulers, rested in Magdeburg Cathedral. They believed that the remains of his distant relative and successor, Henry II the Saint, lay in Bamberg Cathedral. But belief is not proof, and history, as we know, is not always reliable. It is like a labyrinth where truth is often lost behind myths. Nearly 1,000 years ago, Europe was a fragmented, chaotic world. Kingdoms rose and fell with frightening speed, alliances were fragile, and power was won through endless wars and intrigue. Out of this chaos emerged a dynasty that changed the very understanding of statehood, the Saxon dynasty, or the Ottonians. At its center stood Otto I. He was not born an emperor. He became one, passing through the crucible of rebellions and strategic marriages. In 962, in Rome, he was crowned emperor by the Pope, reviving the legacy of ancient Rome and creating the Holy Roman Empire. It was a declaration of a new power. Decades passed, empires shifted, and Henry II stepped onto the stage. Unlike Otto, he was remembered not only as a stark politician, but also as a deeply religious man, later canonized. They were separated by generations, but bound by blood. According to the chronicles, Henry II was the great-nephew of Otto I. It was this genetic trail that became the key to unraveling a mystery nearly 1,000 years old. In 2024 to 2025, a group of scientists, working in the style of a deep National Geographic investigation, decided to verify what historians could only surmise. They turned to paleogenetics, a science that extracts biological software from dead matter. The task seemed impossible. DNA degrades over time due to moisture and bacteria. After 1,000 years, it remains only in fragments, damaged and contaminated by the modern DNA of archaeologists and clergy. But the human body keeps secrets in its most protected places. Scientists focus their attention on the petrous part of the temporal bone. It is the densest bone in the mammalian body, acting as a natural black box that preserves genetic material in its pristine form, even in the harsh environments of cathedrals. It was from these microscopic structures that material was successfully extracted for next-generation sequencing, NGS. To understand the full complexity of the process, one must look inside the sterile booths of the laboratory. Scientists use a method called target enrichment, or DNA fishing. All available fragments of nucleic acids are isolated from bone powder. Billions of scraps, 99% of which belong to soil bacteria, fungi, and the people who touched these bones in the 19th century. To find the emperor's genes, researchers create special molecular baits, synthetic RNA probes that match the human genome. These baits literally fish out from the mass of chaos the few strands that belong to the ancient ruler. This is delicate work requiring weeks of supercomputer calculations. Only after bioinformaticians filtered out all the garbage did the genetic code of those who decided the fates of Europe appear before the researchers. The researchers extracted samples from the sarcophagus in Magdeburg and the tomb in Bamberg. What they discovered changed our understanding of the possibility of verifying the past. First, partial genomes of both rulers were reconstructed. Scientists began searching for IBD, identity by descent, segments, stretches of DNA identical by origin, inherited from a common ancestor. If the remains were fraudulent, these segments would be absent. However, the analysis revealed third-degree kinship, exactly what medieval chronicles predicted. The probability that two people with such a degree of kinship, not belonging to the imperial house, were accidentally buried in two different cities is statistically negligible. But science demanded a final verdict. Researchers turn to the Y chromosome, a direct genetic line passed from father to son, almost unchanged. It is a kind of paternal passport of the lineage. The result was staggering. Both rulers belonged to the same extremely rare haplogroup, R1b-F, TA63331. Today, this marker is found in less than 0.1% of the European population, primarily in Saxony and Denmark. Finding two matches of such a rare type in two historical tombs is like finding the same unique signature on two documents separated by centuries. Furthermore, their mitochondrial DNA, passed down through the maternal line, differed significantly, which is perfectly logical for the Ottonian family tree, where the men of the dynasty married representatives of other noble houses. Every piece of the puzzle fit. Biological reality confirmed historical legend. But this discovery is more than just an identification of names. It is a turning point where bones begin to tell more about life than any manuscript. The study revealed paleopathological details of the emperor's lives. Isotope analysis of Otto I's bones showed that his diet was saturated with animal protein and elite species of freshwater fish, emphasizing his exceptional status in an era when meat was a rarity. But the isotopes told another story. The emperor traveled extensively. The chemical composition of his teeth, formed in childhood, differs from the composition of his bones, which regenerate throughout life. This confirms the itinerant nature of the medieval court. The emperor did not sit in a palace. He lived in the saddle, moving between his residences, palatinates, to personally oversee vast territories. At the same time, the study of Henry II, the saint's remains, shed light on his famous chastity. Legends spoke of a religious vow, but bone scans revealed severe spinal lesions and chronic osteomyelitis. This was not just a malaise, it was an agonizing, debilitating disease that accompanied him for decades. Pathologists discovered traces of kidney stone disease, which in the 10th century was virtually incurable and led to unbearable bouts of pain. It is likely that the lack of heirs was caused not only by faith, but by years of physical struggle with an ailment the emperor endured with incredible courage. We see in him a man of iron will, to wage wars, build cathedrals, and manage unruly dukes, while in a state of constant pain, is a feat that chronicles could not fully describe. Moreover, these remains now fulfill a critical technical role in modern science. Because the dates of death for Otto and Henry are known with absolute precision, 973 and 1024 respectively, their tissues have become the gold standard for calibrating radiocarbon dating. They serve as reference points, allowing scientists to fine-tune the accuracy of instruments for dating other finds from the early Middle Ages. The emperors continue to serve their land even a millennium later, becoming the foundation for the accuracy of historical knowledge. This study raises deeper questions. If science could confirm the identities of Otto and Henry, what else is it capable of revealing? How many tombs around the world hold people other than those whose names are carved in stone? How many kings and heroes lie under false titles due to medieval forgeries or restorers' mistakes? We stand on the threshold of a great revision of the past. DNA knows no politics. It cares nothing for legends. It cannot lie to please ruling dynasties. The genetic profile of the Saxon dynasty also shed light on the origin of Germanic tribes. The R1b-FTA63331 subclade points to deep roots reaching back to the Bronze Age of Central Europe. This refutes some radical theories about mass population replacements during this period. It turns out that the elite of the Holy Roman Empire were flesh and blood of the land they ruled. In the emperor's genomes, scientists found traces of high genetic diversity, indicating that even in a caste-based society, ruling houses constantly refreshed their blood through alliances with representatives from other regions, from Italy to Scandinavia. This makes the history of Europe not a history of isolated peoples, but a history of constant interaction. In Bamberg, the situation was even more complex. Henry II and his wife Kunigunde, also canonized, rest in a magnificent sarcophagus by Tilman Riemenschneider. Here, science encountered art and religion. When the lid of the sarcophagus was lifted, researchers saw not just a skeleton, but a sacred relic. Yet, even sanctity could not hide biological truth. Interestingly, Kunigunde's DNA was also analyzed. Although she was not a blood relative of her husband, which is logical, Her genetic profile confirmed her origin from the House of Luxembourg. This is the first case in history where the authenticity of an entire holy couple of imperial rank was confirmed. The work of laboratories in Leipzig and Harvard to decode these genomes took months. It was a process of fishing out the right molecules from a sea of microbial debris. Documentary evidence that Henry was the son of Henry the Wrangler, who in turn was the grandson of Henry the Fowler, was confirmed at the molecular level. The line of succession, once considered merely the official version, proved to be a biological fact. This gives historians new hope. If the archives of this era proved correct, then perhaps other dynastic chains were not invented by later chroniclers to legitimize power. Scientists now plan to direct their efforts towards studying the remains of the Carolingians and Merovingians to trace the thread of power back to the fall of Rome. The impact of this discovery on archaeology cannot be overstated. We are entering an era where no significant find will be considered recognized without a genetic certificate. This will change the museum world. Labels for exhibits will become more cautious or, conversely, gain unprecedented confidence. We will no longer say, presumably the remains. We will say, verified genome. This also opens possibilities for finding living descendants of ancient rulers. Theoretically, people are walking among us today carrying that same rare R1b-FTA63331 haplogroup, completely unaware of their kinship with the first emperor of the Holy Roman Empire. Genetics blurs the lines between then and now, making history tangible. Every European today might be the carrier of a tiny fragment of DNA that once belonged to Otto the Great. This thought turns dry science into a personal adventure for everyone. Imagine how our perception of the past will change when similar tests are conducted for all the royal burial sites of Europe. Saint-Denis in France, Westminster Abbey in England, the Pantheon in Rome. Thousands of sarcophagi await their hour. We may discover that some great kings were bastards, while others were substituted entirely in infancy. The history we learned in school may turn out to be just the tip of the iceberg, beneath which lie entirely different biological realities. Otto I and Henry II have become the first swallows of this new scientific revolution. Their bones, long merely objects of worship, have turned into the most powerful instruments of knowledge. In conclusion, it should be said that faith and science in this particular case did not enter into conflict, but merged in a single impulse. Faith preserved these remains over the centuries, guarding them from oblivion, and science arrived to confirm the truth of that faith. This is a rare example of harmony, where technology does not destroy the magic of the past, but makes it deeper and more conscious. We look at the cathedrals of Magdeburg and Bamberg with different eyes. They are no longer just old buildings. They are data repositories, biological archives that will be studied for many decades to come. The past has ceased to be silent. It has spoken loudly, clearly, and in a language understandable to any scientist anywhere in the world. And what it told us, that we were not mistaken in our heroes, fills us with a strange sense of relief. 1,000 years later, the emperors have returned to confirm their identity and once again assert their right to eternity. And now this right is anchored not only in stone, but in the very fabric of life. Every molecule of their DNA is a testament to the long journey our civilization has taken from the chaos of the Middle Ages to the precision of the digital age. And this journey, as it turns out, was not in vain. The cathedrals of Germany continue to guard their secrets. But now these secrets are protected not only by church locks, but by the indisputable power of the genetic code. The past has ceased to be a collection of fairy tales. It has acquired flesh, blood, and scientific credibility, turning every ancient sarcophagus into a time capsule, ready to speak to those who know how to listen. And we listen, holding our breath, because in these double helices, not only their history is written, but our own. Today, in the age of artificial intelligence and spaceflight, we have suddenly discovered that the most important answers are still hidden in the dust of ages. We realize that progress is not only a quest forward, but also the ability to look back with tools worthy of the truth. The history of the Saxon dynasty is now carved in eternity by a double code: the ink of monks and the nitrogenous bases of life. It is a union that cannot be dissolved. It is our final reconciliation with the past.